Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, August 11th. In this week's installment, we'll be looking at jet stream level winds, surface level pressure, the effect of winds on the ocean, waves that is, seas, swells radiating from storms towards our coast, and of course, then we'll be looking long term at the MJO and El Nino, trying to get a sense of what's going to happen surf-wise, rain-wise, and also snow-wise for the Pacific Basin. So, let's get into the details. First off, we take a look at significant wave heights for the South Pacific Ocean. Yes, it's still summertime, and the South Pacific Ocean is the main source of swell for California and Hawaii, which is our main forecast area, though we do discuss areas over the greater Pacific Basin. Anyway, we have a gale here in the South Central Pacific generating 31-foot seas, but as you'll soon see, this one is not so much of a swell producer, though it looks at it just looking at a single image on the chart. Otherwise, looking at the Pacific Basin in general, pretty quiet pattern is in play. As usual, we start out looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they do form, help direct their track. We're looking for a trough, and we kind of see one right there, just a little bit of this. So this is the southern branch of the jet here. This is the northern branch here. It's the southern branch that is the most influential in terms of being able to help support storm development. We're looking for a nudge or for it to push to the north. That helps create a clockwise flow aloft, and that is in the southern hemisphere. That's the hallmark of low pressure. And of course, low pressure generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, eventually turn into swell. And swell, when it hits your beach, turns into surf. So we see a little bit of a trough here. Notice there's pretty solid winds here. What is that? 190 knot winds. That's in the northern branch of the jet. Doesn't do a whole lot for storm production. It's this little trough here we're watching. But also notice as you get over into the central South Pacific, there is a ridge. That is, it's pushing south. The ice line's somewhere around 63 south, right about there. And so you can see when the jet pushes south, that produces high pressure, and that pretty much locks down any potential for gale development or swell development. So right here, here's our main area of interest. Let's put this into motion. As you see, we get into Monday. The trough starts building a little bit more, being fed by 120 knot winds pushing to the north. That's good. That offers support for gale development. And that trough continues as we get into Tuesday and then even Wednesday, but it starts weakening maybe Tuesday night into Wednesday. But the southern branch merges with the northern branch, and as you can see right there, winds are to build to 180 knots. So still, some support for gale development is likely in that area as this trough moves over the central South Pacific, and then towards the southeast Pacific, it pretty much starts dying. The jet, notice, under New Zealand, this is Friday now, starts to push south a little bit, and a ridge starts building. That probably will be the end of any decent potential for swell development. Let's just go ahead, or storm development. Let's put this into motion. We're into Sunday. We're a week from now. And yeah, the jet pretty much ridging. What is that? That's about 57 south. So it's clear of the ice line, but it doesn't look like it's providing good support for gale development in the Southwest Pacific. And a massive ridge here a week from now is supposed to be just pushing over Antarctica, shutting any potential down in the Southeast Pacific for gale development. All right, let's go take a look at the surface level pressure, surface level winds. Here we go. All right, so we see there's actually two low pressure systems, one east of New Zealand. Yeah, we saw seas in this area here. What is that? There's 40 knot winds pushing to the south, and then 30 knot winds pushing to the north, generating some seas. But it is the more interesting low is this one south of New Zealand here with 35 knot winds. Now that's not a whole lot. It's not great, but it is a start. We'll put this into motion here. And we see basically two gales, one east of New Zealand, another one southeast of New Zealand, not really doing a whole lot. It's not till Monday that they it's like they call this a complex gale when you have 1, 2, 3 different gales all sort of rotating around some sort of a common undefined core. That's what it is. Lots of fetches. Here we go. As we get into Monday night, almost Tuesday, a broader fetch starts developing. That's only 30, 35 knot winds out of the south. Needs stronger than that. And here we go. We get into Tuesday midday, 45, almost 50 knot winds. That looks pretty good. That's certainly capable of generating swell. And there we go. By Tuesday night, building to 50 knot winds, lifting to the northeast. This actually looks much better than it was even 24 hours ago. I mean, we're looking at just about every run of the model, but you know, to get a sense of what's going on, are any systems getting stronger than what was previously forecast? This definitely fits that category with 40, 45 knot southwest winds pushing to the northeast as we get into Wednesday, and then slowly fading out as we get into Thursday as they move into or over the central South Pacific. Not completely gone, but pretty much fading out. You need pretty much 40 knot winds to be able to generate decent surf, to be able to survive the journey. It's what, about 5,000 miles from this location, let's say 50 south, up into California. So that's pretty much over. High pressure starts building. Now notice another gale tries to develop as we get into Saturday night under New Zealand, but all the winds are aimed more southeast than northeast. And there you go. As you get into 18Z on Sunday, there is fetch, 35, 40 knots, but it's all aimed at Antarctica. The system over in the southeast Pacific, let's just take a look here. So that starts on Saturday, but it's 35, 40 knot winds. You know, this is, and they're 117 west, that's the Southern California swell window, the southern or the easternmost extent of it. So certainly another gale is forecast, perhaps maybe generating very southern angle swell for Southern California, but this looks more like a Hawaii sort of system, or Central America down into, you know, Peru and that sort of thing. So that's good. And then we go out, let's just take this right out to 180 hours, and there we go. Now, it sort of looks like there's generally low pressure to be filling the entirety of the South Pacific Ocean, but all the fetch is aimed either due to the east or to the southeast, and that just does nothing for generating swell to radiate north into our forecast area. All right, let's go take a look at the wave models. Here we go. Significant wave heights for the South Pacific Ocean. As we saw before, gale east of New Zealand generating 31-foot seas. But watch this. It's falling southeast. That is not going to do anything for producing swell up in our area. Tahiti, yeah, sure, they'll get sideband swell, but probably we're betting on nothing for California, but we could be wrong. Maybe it'll be 1 foot at 16 seconds or something like that. We're way more interested in what's developing here southeast of New Zealand on Tuesday. Small area, 30-foot seas, quickly building to 38-foot seas later Tuesday, and then Tuesday night to nearly 40 feet over a small area. There we go, and clearly 40 feet as we get into Wednesday AM. If this materializes as forecast, this could actually produce a nice little pulse of swell, and at least relative to Northern California, it should be unshadowed, right on the hairy edge of the Tahiti swell shadow here. So the swell would creep up or over the west side of Tahiti and then up into the Northern California coast. Southern California, a bit more shadowed. I mean, it's a very thin window there. Just if you saw the Great Circle pass, it's running right along with core of the fetch here. Anyway, so we'll roll this out, and then that gale continues into Wednesday evening with 36 or 37-foot seas, then moves clearly into the shadow, starts fading. Still, you get swell through the shadow. It just cuts down the number of waves in set, cuts down the size a little bit, and just cuts down the consistency significantly. And then the gale pushes east as we get into Friday, and pretty much fades out. Another system, note this, trying to develop under Tasmania. Also remnants of this system. Let's watch this for a second as we get into Saturday. Redeveloping supposedly with 28-foot seas here in the southeast Pacific, aimed pretty well to the north, building to 30 feet on Saturday night. And then we get into, Sunday morning and 34-foot seas, but mostly out of the Southern California swell window, certainly not in the Northern California swell window. This looks primarily like a swell for Mexico and down into Central America, if it materializes at all, because we're nearly a week out. And there we are at 180 hours. We see activity under New Zealand, but we already know all the fetch is aimed to the southeast at Antarctica, and so nothing will be radiating north towards us. Taking a quick look at the North Pacific Ocean, I think we're down to tropical storm force Crosa. Maybe it could be, perhaps still be a hurricane. This system is not expected. You just watch it here. It moves into, it's forecast to move into southern Japan, actually redevelop back to a hurricane force, but impact land there. No recurvature to the northeast, not getting caught by the jet stream. That said, notice a generalized pattern here of developing not like swell producing seas, but certainly an upgrade from just dead flat. Also watch here in the Gulf of Alaska as we get to 180 hours out. Small area, 18-foot seas. Do we believe that? Not a chance. But it is really interesting. If you've been following the models for the past couple of weeks now, there's been these series of weak low pressure systems that are developing in the Gulf of Alaska. If it were an El Nino year, we'd say this is interesting. But it's really not an El Nino year. We're fading out of El Nino. But this is pretty typical of when you get in that sort of situation. The hangover from El Nino makes the season look like, hey, we're going to get off to an early start. In fact, you might get some activity and you really go, hey, this winter's going to shape up. And then, depending on what El Nino does, but typically, at least what we're looking at the models, it will fade. And so whatever sort of a pulse you see setting up for the long-term winter forecast, it isn't going to happen. But we'll get into that a little bit more. So then our other option is wind swell. So let's go take a look. Right now, here, we'll pull this down so you can actually see the dates. There we go. All right, California, winds are light. Little area 15-knot winds off of Point Conception. That's doing nothing for generating wind swell. There's one of these. This is actually like the second or third in the past couple of weeks. We've seen low pressure system, very weak. 1,008 millibars, approaching the central Gulf of Alaska, sort of cutting the legs out of high pressure. Yeah, we have high pressure, 1020 millibar high, generating trades, but pushing south of Hawaii, so really no wind swell production for Hawaii either. We'll put this into motion. A little bit of fetch is to try and develop off of California on Monday, but 15 knots, that's good for 6, maybe 7 second period junky wind swell at best, and not even pushing into the coast, so probably nothing rideable from that. Fetch, yeah, a little bit better off the south end of this high here. High pressure in the northern hemisphere, rotates clockwise. That gets you, easterly fetch. Sort of pushing at Hawaii as we get into Monday, but nothing too significant. That low pressure still in control. Let's go to Tuesday. Same sort of deal. A little bit of more fetch trying to develop east of Hawaii, but just not very cohesive, not very strong because the high is weak. This high pressure here, of course, generate clockwise flow, and so it's trying to get the gradient going along California. Then finally we get into Wednesday. The low starts fading, the high starts building. We get 20-25 knot winds off of Northern California. That should generate some wind swell there for North California, radiating down into Central California later in the day. It also helps start feeding these easterly winds pushing towards Hawaii. Maybe some potential to develop more wind swell, especially later on Wednesday. Look at this, 25, almost 30 knot winds here for Northern California too. Get into Thursday, that's when the wind swell machine really starts kicking up for California. 30 knot winds off of Northern California with light winds over Southern California. And the fetch east of Hawaii building too, so wind swell, both locations. Friday, even better. Notice no low pressure here in this frame, but you kind of get a hint of something way off here to the west. But in the meantime, probably decent sized wind swell, 20-25 knot winds over all of California. Choppy mess, find a protected break. Hawaii looking good. Fetch the whole way from California, 15 to 20 knots pushing into the Hawaiian Islands. That'll generate wind swell there as well. We get into Saturday, and all of a sudden, the high just loses its mojo. Residual wind swell probably for the Hawaiian Islands. Then we get into Sunday, and I wonder why the high was fading. Look at this. Low pressure supposedly developing with 35 knot winds aimed at Northern California. Let's stretch this out to see. Yeah, 30, even a little tiny fetch of 40 knot winds. Do we believe that? Not a chance. This is a week out. So this will be an interesting test because we're up to this is the newer version of the GFS model. I think it's version 15 or something that came out or was officially released 2 or 3 months ago, something like that. A little bit better math, a little bit better physics involved, maybe a little bit more accuracy long term. We'll see. Certainly from a tropical perspective, what we've seen is it's doing a better job than what the version 14 used to do. So this is interesting. Anyway, and there we go. 180 hours out, now all of a sudden, boom, 40 knot winds out of the northwest. Do you believe that in, where we say, August 19th, Sunday evening, August 19th? The 15th of August is where we typically start looking for activity in the North Pacific, so it's not out of the realm of possibility. Would I expect it to happen? No, not a chance, but we'll keep watching the models. It's a reason to keep looking, and it gives us a little bit of hope. All right, let's take a look long term. What's going on with the MJO, Madden-Julian oscillation that runs from west to east over the equator, from the West Pacific to the East Pacific, just on the equator. When in the active state, it's basically like a big low pressure system that can feed energy to the jet stream. It can also help support the formation of gales in the North Pacific in winter months and in the South Pacific in summer months. And then, of course, El Nino or La Nina or whatever state that we're currently in. All right, let's get into it. Okay, as usual, we like to look for the presence of the MJO, and one way to do that is by winds over the Pacific. Here's the equator. Right here, 0 degrees. This is the East Pacific here. This is the West Pacific here. There's New Guinea. There's the date line. The area that we're really interested in is the Kelvin Wave generation area. This area right here in the far West Pacific. And as we see, winds are from the east, pretty strong. Again, these winds are from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino. And these are 5-day average winds, but they give us a good indication of what's going on. Sort of takes some of the noise out of it with that 5-day average and gives us a sense what's going on MJO-wise. So winds clearly strongly out of the east over the East Pacific and continuing into the Central Pacific and to the date line even. But in the far West Pacific, winds far lighter, pretty much almost calm, or I wouldn't say westerly, just light or calm. But it is the anomalies, difference from normal for this time of year. That's what really matters. And looking over here, we see, these little arrows, they're out of the east, so that these winds here are a little bit stronger than normal for this time of year. Same thing over the Central Pacific, same thing over the date line, and then weak westerly, supposedly, in the far West Pacific. In the Kelvin Wave generation area, this area from 5 degrees north to 5 degrees south, from 135 east to about 170 west, right in there. If you get strong, long-lasting westerly anomalies in this area, and if there is warm water here, then you can get what's known as a Kelvin wave. And it's basically a ball of warm water that travels under the equator, erupts off of Ecuador, and then forms a warm water slick. But look at this. You see this? So these are actual water temperatures here. We're seeing negative water temperatures on the ocean surface, 1 degree below normal. That is clearly not the sign of El Nino. It's the exact opposite, the sign of La Nina. Though officially, NOAA came out with their forecast last week and said ENSO neutral, El Nino neutral. So not El Nino, not La Nina, just dead neutral. But we'll talk about that a little bit more in detail. Right now, we're focused on the MJO. So this gives us a sense that maybe there's some weak active MJO thing going on right now, but it's limited to the far West Pacific. It hasn't started migrating east yet. All right, let's go look at more data. Here's the forecast for sea surface winds for the next week, and also what's been going on for the past month or so. All right, so this is the whole planet. Oh, here, we'll scroll that up. Whole planet on one chart, 180 degrees. That's the date line. So the Pacific is from about, 90 west to about 130 east, something like that. So that's the Pacific Ocean. If you scroll up this chart, you can see, but it's the Kelvin Wave generation area from about 135 east to 170. That's the area we're really interested in. And you can see these reds are westerly anomalies that were in the Kelvin Wave generation area back in mid-July or so, back when we actually had surf, back when there was real waves, weeks of waves. This is the hallmark of the active phase of the MJO, and that was a contributor to the formation of the gales that produced the swell, that produced the surf back in July. But since then, you get this sort of sense of, in the Kelvin Wave generation area right here, sort of this mix, but mainly the blues or easterly anomalies, and then strong easterly anomalies on the date line the past week. This is probably a pretty good indicator of the inactive phase of the MJO, and the inactive phase of the MJO steals energy from the jet stream. Doesn't mean you don't get storms, but they're usually not as strong, don't last as long, and are harder to come by. Anyway, the forecast for the Kelvin Wave generation area as of August 11th suggests that these easterly anomalies are to be dying in the next 2 to 3 days, and we return to sort of this mixed, basically neutral pattern. A little bit of westerly anomalies, a little bit of easterly anomalies. We'll call it MJO neutral, but that's certainly better than the inactive phase of the MJO. Here's another model. This is the outgoing long wave radiation, or a fancy word for cloud cover. Where you see the blues, that means more cloud cover. More cloud cover pretty much means low pressure, which means the active phase of the MJO. Hey, this is looking pretty good. This is the statistic model. It suggests the active phase of the MJO is building, supposed to peak about 10 days from now, and then start withering or fading a little bit. This would be a good window to support storm development in the southern hemisphere or in the northern hemisphere. But the dynamic model, not nearly as aggressive or favorable. Just basically saying, yeah, some tendency towards the active phase, and then it just dies out and goes dead neutral. But you know what? Either of these scenarios is better than the inactive phase of the MJO, so we'll take it. Phase diagram charts are up next. Basically another way of looking at the MJO. Assume you're looking down on the North Pole. So this circle is the center of the circle is the North Pole. The MJO goes on the equator from west to east, from the Indian Ocean over the maritime continent, over the West Pacific, over the East Pacific, under the United States. Remember, it's on the equator, across the Atlantic, over North Africa, back to the Indian Ocean. The active and the inactive phase are basically, if the active phase is here, the inactive phase is over here, and they sort of rotate around the planet, on and on. But stronger, weaker, it varies from the season to season. So according to this, the statistic model, and there's 3 different flavors of it. You can see here, and the further the MJO is away from the circle, the stronger it is. So we'll call it a modest MJO signal over the maritime continent. That's like Bali. And forecast to move towards the West Pacific, but you see just getting weaker and weaker and sort of collapsing. The dynamic model, the GEFS model, says basically the same thing with the MJO active, very weak, noodling around somewhere between Bali and, let's say, New Guinea, and just really not doing a whole lot. That's over the next 2 weeks. This is the upper level model, used mainly for tracking precipitation. So areas of green are favorable for precipitation, and one could generally say that's the active phase of the MJO. The reds and oranges are not favorable for precipitation, the inactive phase of the MJO. So you can clearly see inactive phase of the MJO moving out of the Pacific. Now this runs about, in the upper levels of the atmosphere, runs about a week ahead of what's actually going on at the surface. So it's racing around, faster in the upper levels of the atmosphere. And because of friction or whatever you want to call it, it sort of drags behind, gets pulled behind down at the surface. So anyway, inactive phase moving over Central America today and pretty much moving into the Atlantic over the next week or two. A weak active phase, you can see moving into the Pacific, but kind of disjointed, not particularly organized, but sort of hanging, slowly meandering its way, and almost like a second lobe of it trying to organize, but just, sort of a mixed bag pattern here through, September 10th or so. And then finally, supposedly, a stronger, more cohesive version of the inactive phase of the MJO sets up mid-September. So at the surface, let's say late September. So the time frame, it looks like, for swell production would be from, let's say, starting about 4 or 5 days from now into about mid-September or so. And then things might go quiet again for a little bit. 850 millibar wind anomalies. Again, this is the whole planet on one chart, date line running right up the middle, Kelvin wave generation area here between, let's just say, these two tick marks going up. Again, you can look at past performance. These areas of red are westerly anomalies. That is, or was, the active phase of the MJO. Dotted contour here, inactive phases back in June. Here's that July time frame where we had all that that surf from like late June into about somewhere in July, mid-July. Then things sort of fell apart. The forecast, you can see, you get a hint that maybe this is all that there is right now of the this dotted contour, the inactive phase of the MJO, and pretty much fading out here's today. Now, no real active phase indicated per this model, but westerly anomalies. So here, these easterly anomalies, they're supposed to be gone in about 5 days. And then westerly anomalies take root in the Kelvin wave generation area. And this, again, is indicative of a building pattern or a favorable pattern for storm production, not only in the southern hemisphere, but also in the northern hemisphere, and maybe also some tropical development as well. So again, this mid-August to mid-September time frame is looking reasonably favorable at this point in time per the models that we have access to. And then the real long-term outlook, going out 3 months. Okay, so this is a little bit different. Same deal. All planned on one chart. Kelvin wave generation area between these two tick marks here going up the chart. But past history is down here. The forecast is the top half of the chart. Basically, no real change. The good news here, see this big thing pretty much going the whole. So this is this is westerly anomalies in the West Pacific from now till November. Westerly anomalies, of course, indicative or favorable, indicative of the active phase of the MJO and favorable for gale development both in the North and the South Pacific. Let's overlay the MJO phase. Now, here you go. Here's where we are right now, right here on this line, kind of just in a dead zone. Supposedly, a weak inactive phase is going to set up in August, but westerly anomalies holding good, and the inactive phase very, very weak. I mean, here's a strong active phase, here's a moderate inactive phase. You see here the pattern just to be extremely weak the whole way through fall in terms of the MJO. So it's not going to give any storm development a lot of push, but just westerly anomalies in and of themselves should do the trick along with the seasonal change. Active phase, though, weak, supposed to develop mid-September into late September. So again, we'll see. And then the inactive phase after that. But here's the interesting part, the low-pass filter. All right, we've talked about this in the past. It was supposed to completely die out. So the low-pass filter, these solid contours here, is the equivalent of a low-pressure bias. And notice it's straddled right over the date line here. And a low-pressure bias, that's like, a permanent low pressure in the Pacific Ocean on the date line. That's typically the hallmark of El Nino. Now, supposedly El Nino's dying, but according to this, we'll say, some flavor, I wouldn't even call it El Nino, but just a general bias supportive of storm development looks to be holding over the date line into at least, we'll say, mid-November and maybe beyond. So this is kind of interesting. A couple of weeks ago, this was all supposed to die out, and the low-pressure bias was supposed to move to the Indian Ocean. We go, oh my gosh, it looks like La Nina's coming. This does not support that at all, at least this one version of the model. It sort of looks like, just a ENSO neutral, but maybe slightly biased towards El Nino. But again, even if El Nino, like Noah's saying, El Nino is dead and we're at neutral, but there still appears to be some weak bias in the atmosphere for it, and it's supposed to hold, according to this model, into the fall. That's good news. All right, let's go take a look at the ocean. Why do and subsurface sea surface temperatures. Why you want to do that? Well, that gives us, we talked about Kelvin waves, right? Kelvin waves, balls of warm water or pockets of warm water moving from the west to the east under the equator. All right, so we're looking for the presence of Kelvin waves, and that in turn could help us identify whether we're still in El Nino or not, or whether we're in La Nina. If you have cool water, then that's definitely a sign of La Nina. Right now, warm water in the West Pacific. Again, this is from the TAO buoy rate. This is the East Pacific here, West Pacific here. Here are the anchor lines on the TAO buoys. The X's are the sensors on the anchor lines. All the data is relayed via satellite to a central processing facility. They build the charts, use a model to fill in the gaps, and then we get to look at it and monitor along with NOAA and everybody else what's going on in the Pacific Ocean. Anyway, so we see warm water in the far West Pacific Ocean. There's the date line. And then that warm water getting cooler and not as deep. A shallower thermocline is what they call it as we move to the East Pacific. Okay, so what's that mean? Well, here's anomalies, differences from normal for this time of year. We see a pocket of 1 to almost 2 degree anomalies on the date line. Looks like a little bit of a Kelvin wave. We had a westerly wind burst. We saw it on the previous charts back in July. That helped take warm water that was in the west. When you have west winds blowing here, starts pushing it to the east. It falls to depth. So that's almost a Kelvin wave, but not really. Pretty weak. But you see this generalized warm water pattern the whole way over into the East Pacific. That's good news because we were seeing cool water building. Yeah, there's still a little pocket here, but it looks to be fading, at least from this modeled view. And warm water seems to be encroaching off to the east a little bit better than what it was, suggesting that, well, maybe, I'm not saying we're getting a rebuilding El Nino here, but it doesn't appear that we're moving towards La Nina. Here's another modeled view of the same thing, just a different model, same raw data. You see our Kelvin wave. It's not really going anywhere. It's like stationary. This is pretty typical of like what you call a Madoki El Nino. It's sort of like El Nino, but not really. You get the Kelvin wave, doesn't make it to the east. Here you see cool water in the East Pacific. This sort of makes you almost feel like La Nina, but you're not really there either. It's just kind of this mixed bag. This view is not as optimistic as the previous view, but it's not completely pessimistic either. So looking at this, probably say ENSO neutral. Sea level anomalies, basically this is JSON2 satellite, strip out all the waves, strip out the wind waves, strip out the tide, and it shows these oranges are like a bump, a little hill on the ocean surface, 5 centimeters. It's only right here on the equator, 5 degrees north and south of the equator that we're interested in the Kelvin wave generation area. So so what this means is if you have warm water at depth, well, that sort of warm water expands, creates this little bump on the ocean surface, and that is what basically just another way to confirm what's going on subsurface. Also in the East Pacific here, see negative anomalies. That means cooler water contracts. You get a little depression on the ocean surface. We're talking 5 centimeters. That's not very much, like 2 inches or something. You know, it's amazing that the satellites are this sensitive and that all this stuff works. But and it's very impressive what you can do with this technology to use this to infer what the temperature of the ocean is 100 meters. That's 300 feet down into the ocean. Pretty cool stuff. Anyway, so you see, yeah, sort of like a Kelvin wave trying to organize, but we know it's not moving east anyway. And it's hitting, you can almost see it, it's trying to push to the east, but it's hitting headwinds and cool water pushing against it. We're going to get into that in a minute. Upper ocean heat anomalies over time. This is the West Pacific here, East Pacific here. The oranges and reds are warm water. This is Kelvin, I think this is what, Kelvin wave number 2 at least, back October of last year, going from the West Pacific to the East Pacific, driven by strong westerly winds, active phase of the MJO. You know, this is when we were in supposedly El Nino, but it was a pretty weak El Nino. And then January of this year, Kelvin wave number 3. Strong, more intense, but not as broad. Didn't even make it really to Ecuador. It stalled, sort of this Madoki El Nino thing. It stalled south of California. Then even a weaker Kelvin wave back in the June time frame, and then we had another westerly wind burst in the July time frame with that active phase of the MJO and the swell that we got then. Even weaker Kelvin wave right now, stalled pretty much on the date line, going nowhere. No warm water in the West Pacific, so even if we did get some, you know, magic strong MJO thing there, and it created westerly winds, there's no warm water to make another Kelvin wave. This was a shocker that we even got this. We expect this is probably the end of the Kelvin wave cycle for a while. All right, sea surface temperatures. That matters even more. You can have your Kelvin waves and they're all, like under the equator, under the ocean surface, but you got to have warm temperatures on the ocean surface to create evaporation, and evaporation then feeds the jet stream, and the jet stream feeds the storm track, etc., etc. So right now, you see cool waters off of Peru. Here's Peru. Chile's down here. It's not really cool, but cool, and running along the equator, pushing off, and building in coverage off to the east, to the west, to 140 west, okay? And you go, well, look, there's warm water all around it. So the real deal here is this is all leftover warm water from El Nino. It's sort of radiating away from, the equator, but this new cool water, this sort of like a dagger in the heart of El Nino, is pushing. It's not strong, but it's dribbling along. This latest Kelvin wave, which is way over here by the date line, probably isn't going to make it anywhere because it's being impacted. We saw that some of the other charts by the cool water here, and we're just sort of locked in this frozen position where it's sort of like La Nina with the cool water, sort of like El Nino with the warm water, but neither of them is very strong. The MJO cycle is extremely weak, and we're kind of locked in this neutral pattern. Here's the trend for the past 7 days, and this is a little bit of improvement. So what we have been seeing is cool water here radiating off of Ecuador along the equator, and you can see, oh, look at that, cool water almost, or a cooling pattern building out almost to the date line now, okay? But notice also, just recently, slight warming around the Galapagos. Still, we think the trend is, and you can almost see it off of Africa here too, this sort of cooling trend. It appears that winds, or the upwelling cycle, or the countercurrent here on the equator is favoring cool water, and that's certainly not favorable for any El Nino. And not super favorable for storm development in the winter months either. Here's the backed off view, plain and simple to see, cool water off of Peru, Chile. You see so the trades, what do you got? High pressure here, driving cool water up the coast. It hits Ecuador, the Galapagos, and then starts radiating this direction, the exact opposite of Kelvin waves, which would be generated here, radiating this direction. And the cool water appears to have the upper hand. I mean, just eyeballing this, if I saw this, I'd go, yeah, that's a La Nina pattern. Not a strong one, but it looks like La Nina. Certainly doesn't look like El Nino. Yeah, we got a lot of warm water over the oceans. That's not related to any of this. It's just the oceans in general are getting warmer. We're not going to go down that rabbit hole and discuss that for the moment, but it is a fact that the oceans are getting warmer, and it doesn't take much, like a quarter, tenth of a degree kind of thing. So the difference between neutral and El Nino is the difference between 0 degree temperature difference and half a degree over a 5-month period. So this clearly looks like La Nina for now, though the models aren't quite saying that yet. Let's go take a look at some other surface temperature data. This is sea surface temperature trend in the Nino 1.2 region. That's that area right there along Peru and the Galapagos and out, I think it's out to about 120 west. The trend, you just eyeballing this, that's neutral right there. We were warmer and normal in peaks during May, steadily downward. Today's value, half a degree below normal, 0.553. And odds are, if you drew a line through this, you could see downward trend. It probably isn't heading positive, meaning no indication of El Nino in the Nino 1.2 region. The Nino 3.4 region, that's the official El Nino region from a point basically south of California, 120 west out to almost the date line, 170 west, 5 degrees north and south of the equator. Today's value, 0.017 above normal, so basically dead neutral. Not cold, not warm, just in the middle, right? But again, if you put a trend line through this, definitely looks like temperatures are heading down towards, we'll say, neutral. All right, what's going on in the atmosphere, okay? The ocean changes, the atmosphere responds to it. It responds to differences in temperature in the ocean temperatures on the surface over the equator. One way of doing that, and the only one that's really working right now that we have access to that gives you daily readout, is the Southern Oscillation Index. Difference in pressure between Darwin and Tahiti. When you have lower pressure in Tahiti, the index goes negative, and if it stays negative for a week or two, that's indicative of the active phase of the MJO. If it stays negative for months on end, that's indicative of El Nino. All right, right now the daily contribution plus 2.12, and you can just see down here the past 5 or 6 days it's been positive. Prior to that, sort of a mixed bag, and prior to that it was negative. That was our active phase, the MJO, going neutral and now going inactive. 30-day average sort of washes out the noise. The value is minus 1.36 and heading up from what we'd say, where was it? It was down at minus 14.7. So from the active phase moving to a neutral phase. The 90-day average used for monitoring El Nino, minus 6.62, but it's creeping up. It was down around minus 8. Yeah, steady minus 8.5. Now we're at minus 6.62. So probably a slowly fading El Nino pattern. And then finally, the sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region in the Pacific Ocean, per the CFS version 2 model. So we can see back October, January, we had temperatures 3/4 of a degree above normal. Weak El Nino at best. And then slowly through this summer, temperatures have been falling in that region, indicative of a return to ENSO neutral, neither El Nino nor La Nina. That's about where we are today, August, right now. Now, the good news is this model was predicting a definite turn towards La Nina. That has completely vanished from the model. Right now, temperature is supposed to bottom out at, what is that, about 0.25, quarter of a degree below normal in January. That is not La Nina. Certainly not El Nino, but it's not La Nina. And then building as we get into April. Don't believe any of that. But the good news here is no turn to La Nina, just returning to sort of a soft landing, if you will, from El Nino to a neutral state for this winter. If that's the case, we'd be in great shape. So to wrap it up, for now, not a whole lot of swell in the water, but a little gale forecast. Little swell probably to result. That gale developing on Wednesday. Wind swell in the meantime, so something to ride. A little bit of hint of the North Pacific maybe starting to wake up, a week out or so. So, hey, change of season. Hard to believe. We're already through, almost through summer already, and we're starting to look at possible gales in the Gulf of Alaska. We think that is probably a little bit of a red herring, but either way, the North Pacific will probably be a little more active than you suspect from the hangover of El Nino, and everyone will get all hyped up, and then you get into Thanksgiving, December time frame, the bottom's going to fall out, and we'll just sort of have a normal year. Nothing great, but nothing bad either. No clear signs of La Nina developing. Rainfall for California, theoretically, it should be normal, but that seems hard to believe. We've had 2 big rain years last year and then 2 years before that. I would guess the snowfall levels or snowfall amounts in California probably a little bit less than normal. And even if it's a weak La Nina, then the storm track tends to move further north. If you're chasing snow, then Pacific Northwest up into British Columbia, that sort of thing would probably be the prime target if you're traveling for snow in this winter. And you can also hit the subscribe button. You'll get a notification. There's also a bell next to the subscribe button. Click that. You get a notification every time we post a video. It'll get emailed to you. And then you can just directly connect, watch the video, enjoy it. So that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.